Welcome, part 11, 10, 11, something like that, of our self-built printer series. So, yeah, today, basically, I didn't do anything since the last time because I was not home. So we basically pick up exactly where we left off. This means I didn't design any new parts for the bat, which was missing. And yeah, here we go. And basically what I thought was that today we can build the tool head, which is still open to do. And I want to do some preliminary electronics. I already flashed Clipper on the small mainboard, and basically my idea is just to have like a basic Clipper configuration running here, that we can move the printer. Because my goal is more or less to get something working quite quickly, because I want to see the printer in action to just like check if everything works as I expect, and I'm pretty sure it does not. Hey there, Harlem. So yeah, step one of the operation will be a little bit switch wire related. We have the self burner here, and I want to pull out the gears of the extruder, because these are like semi high quality parts, aka the cheapest I found at the time. So I don't want to have them here in this printer. I actually ordered some nicer gears that are more precise. So these parts will go into the new printer for now, and then once it like deemed itself worthy, it will get some better parts. But for now, let's just use the cheap ones from this printer, move it over to here, and build the new tool head. That would be step one, and then step two would be wiring everything up and just like making it nice and working. I have a bit of concerns around the stability of the tool head, because it's really easy to kind of like move the tool head. I'll show you in a second. Like just like back and forth, like it's really wobbly. So potentially we have an issue there that needs some redesign. And besides that, I do not, I didn't work on the printer parts yet for the bed mount, but we did print the missing parts last time. So what we can do is we can somehow mount the bed with the current mounting, just like to have a bed in there. So technically we would have electronics, we would have a print head, and we would have a bed. So we could print something. I'm not quite sure if we get this far today. Hi Joseph, hi Steve. So yeah, let's see how far we get. So step one, let's pull some parts out of here, and then let's build a tool head, and then let's see how fast we go. Because also something I didn't do yet is flash the Clipper firmware on the tool head board. That is, no, this is the motor, I think. Yeah, this is the motor. So we have one of these, and okay, somewhere in my magic box, I have the tool head board we will use, which is a canvas tool head board, and we definitely have to flash Clipper on that, but that should be relatively straightforward, I guess. Let's see. Yeah, this one, I fixed some issues. Basically, I was just like troubleshooting, because I'm still not quite happy with the print quality. And I solved a few issues. I kind of like created some new ones, I guess. Because basically what I now did is I have a new Bowden tube here. Side story. Because what I noticed was that like on this half of the bat, so basically from the center over, I had really uneven stacking of layers. And after a little bit of trial and error, for example, like just moving the part from the center to here and front back, I kind of figured out it's really just like this half of the bat, ignoring the Y. And then the solution was basically what happened is that when the tool head moved basically in this direction, the filament without the Bowden tube was pulling slightly on the tool head, and that caused the uneven layer shifting starting exactly off the center of the bed. I don't know. So yeah, that's why I now have the full Bowden tube here. And I thought I didn't need one because, like, for example, the Prusa Mark III, right, doesn't have a bone tube. Many of the direct drive Creality machines don't have bone tubes. The problem is, I think, that my Bowden is attached here on the side. Here, it comes in here, so it's like attached from the side. And all the machines that don't have Bowden tubes have the filament kind of like anchored directly in the center. So it's always coming straight down, whereas mine comes from the side. And I think that's the problem is if it comes from the side, you always like start pulling filament from the spool basically when the tool head moves over here. And then like when you move over here, the tension lessens, and then when you move back, you pull the filament basically again from the spool. Whereas if it's in the center, it's kind of like always the same. So that's kind of my attempt of an explanation what's happening there. I'm kind of like quite crooked today with my camera. So basically we just have to see how we do that. I think it's best to just unplug that, to be honest, because we just need to strip down the extruder completely, more or less. So, here we go. And I think it's just these two screws. And it should come off. I do not. Here we go. Oh yeah, the probe is of course attached here. I did not consider that. Acrobatically hold this and grab another tool. I have a tube on the side facing upwards that makes a turn down to this extruder. That's kind of what I have here too, right? Like on the side and then down. And I think that works fine. The problem was basically just... Wait, can I just... Let me just unscrew the entire board. We don't have to fill around with any cables. That should come out. I only have to unplug this. Let's also unplug this. Okay, let's just unplug everything. Hi, Sven. If I can. I remember that these are also a little bit painful to get in. Okay, let's do the original plan and just remove the board. I don't want to spend too much time on this. I'm not sure it's... What am I missing? Yeah, that's just a little... Whoop. Okay, cool. Success. Success. Turn by 90 degrees and use a longer tube. At 90 degrees, you mean like facing forward? Yeah, could do that. But like this works now. This is perfect. Like this definitely solved the issue. So now it's just something else. Like I have really bad acceleration values on X, and I don't understand why. Like I triple checked everything is tight and everything is good. But I get really bad acceleration values. And I think that's part of the issue. So like also here, there's just like tons of ringing on the test prints, which something like that wasn't there before. So I did something that caused that, but it's not the bone tube. Facing to the ceiling. I cannot do this because the printer sits in a shelf and there's no space above. So that's really like the reason why I route it this way is because I have no vertical clearance whatsoever. I will replay your stream tomorrow. Checked in too late. No worries, man. Thanks for checking in. Oh. Yeah, it's like the vertical space is really like a bit of pain. That's also the reason why I have to route the bone tube on the underside. That's why I added these like long end stop blocks here. So basically this space is just needed to route the cable and the tube, because above there's like less than 2 millimeters. It's basically the screws are almost touching already. It's just fitting. So yeah, that's just like from the way I store the printer basically. Wait, why is it so hard to get out? But yeah, I also hope by basically just rebuilding the tool head that I somewhat solved my acceleration issue. I was thinking of leaving the tool head off and attaching like accelerometer to the carriage basically directly, to see if the bad acceleration values come from something on the tool head or from the carriage, or like from the rail or something. So it's something I will do over the weekend. Not super urgent. I forgot how this goes together. Here we go. Okay, so the only parts we need are the gears. So it's this gear and also the idler. Let's just get this out. And then these I will just replace with higher quality parts. I kind of have the suspicion, like before I had the ringing issue, I also had like uneven extrusion. And I kind of have the suspicion that's due to the gear. That's also like, just to eliminate that, I'll just swap it out. Let's just quickly get this out. So these parts are what we need. And for the rest, I'll just kind of stack that here on the printer. And then I'll put that back together tomorrow. Let me get this out of the way, and we have some space. Dealing without dropping something or like killing the camera. Success. So then let's transition. Hi, Jordi. I see a broken switch wire conversion. It's not broken. It's partly disassembled. we had to steal some parts. Not steal. The switch wire will get the nice POM gears, and this machine will get the cheap ones. Okay, so basically the issue I mentioned before, where I'm like a little bit concerned, is that there's a lot of like a lot of give when I press. Like left right is okay, but like in the Y direction there's a lot of give, and it's partially because the rod kind of like goes down, but I think the other reason is that we didn't tension those screws here fully. So like this like clamping part here is not fully tensioned, because inside we have the IGUS bearings, and if we fully tension this part, there's too much force on the bearing, or on the bearing technically, right? It's, I missed the word. Bushing. There's too much force on the bushing, and then basically just clamps down on the rod. So that's why these 4 screws here are not fully tensioned, and I think that's part of the reason why this is like not as tight. I mean, we can actually quickly try that, to be honest. So if we just tighten these down, because then it would mean that we just need new parts here, which we need to do anyway. So we just need to change the tolerances, but it's still like quite flexible. So this might be something we need to revisit and change, which I'm not a huge fan of. Yeah, but let's worry about it later. For now, let's build the tool head. And first, like if it prints in any way, shape, or form, that's a success. And then we can like start iterating and improving things. Let me also, I mean, now you can see like I cannot move this anymore, so it's completely clamped down. That's why we had them a little bit loose, which also like not really a solution. Now I can move it again. So yeah, that definitely needs tweaking. So basically we need to just reduce the tolerances of the part so that it's like further apart. Yeah. One thing I was thinking about here was like adding a third rod actually, because if you add a third one, it gets much stiffer. So that might be required, which would kind of suck, but I guess we have the space here, right, to have like a third one on the bottom and have like this like triangle configuration. That would be a solution. Potentially we can even think about adding it on top, because there's also like lots of space. So something like this. But let's see. Let's first run it with 2 and then step by step. So yeah, so this is our like hot end placeholder, which we will definitely not use. This was the defective hot end that was like leaking up here. Caused me a lot of trouble. I'm very angry with this one. For now, we will use this like very cheap Ender hot end basically. Again, like for the beginning, cheap parts, that's all fine. And if I see that the printer is like performing well, I can always upgrade to like better parts. The twisting head shouldn't be too hard to fix, just need to move those 2 rods farther apart. Yeah, that's also an option to just move them farther apart. It's just like there's a little bit of a constraint with the part itself, because if I move them further apart, I lose build volume basically. So there's a reason why they're that close. Yeah, I need to see. Like that's something we will need to check in CAD and just like go over it and find a solution. But for now, I don't really mind. It's okay. Like I expect the first prints to be super crappy. And then we can just find issues like that and address them one by one. So there will be some some fun left after the first print. Maybe increase the space between the 2 rods of your AB gantry to increase rigidity. Yeah, I think Sven, that's the same that Sandman also suggested. Oh, Sandman, also like totally missed your first comment. It looks like Core XZ. Yeah, like the other machine down, that's a Core XZ. That's a Core XY. So, I'm not quite sure why the screws here are a little bit tight, but I think this wants to be drilled out. Come on. Oh yeah, I totally forgot. I printed these parts a couple weeks ago. They were quite something wasn't quite right. They fit really. They fit, but they are like there's no clearance basically. Like they're really snug. Oh yeah, and this part is not the standard mini stealth burner. We need to check the manual for that. We don't have to assemble it now, but later there will be like magnets in here for the slide swipe, which is like a clicky adaptation. So basically we'll have like a clicky probe docked to this side of the tool head. Okay, so we have tons of parts here kind of flying around. I think it's, oh, I also forgot the other printed parts. Let me quickly grab the rest of the printed parts. And then I think it's smart if we just like walk through the manual of the mini stealth burner / the V0 to assemble this together, because I'm pretty sure if I do it by like just by memory, something will be forgotten. Okay, let me quickly grab the parts and I'm right back. We have parts. Hey, the thinga. No, partially these are the bad mounts. Let's see if we need them. These are the bad mounts we printed last time. So let's just actually put them perspectives back and park them somewhere over here. I don't think we need them. And then we have the rest of the extruder parts. Let me also quickly find the tool head board. That should be somewhere in this magic. Here we go. Yes, it's chaos. And that's a later project, and this one as well. Park that. Okay. Then let's quickly check for the manual. Because without the manual, we will screw up. Oh. Oh, that's a PDF link. Interesting. Let me quickly open that in Chrome. Here we go. Okay. Then we are interested in printhead. No worries about the mess. If you could see what a mess my room currently is due to electronic parts lying everywhere, then that part's organized. Yeah, the problem is, I think it's a feature, not a bug actually. So this is my living room. And I'm kind of forced to, after the stream, clean up everything. So this is my dining table. So what I did actually is like I have these project boxes basically. When I'm done, basically everything goes in a project box. So the chaos is quite limited in a certain sense, because like it's very easy for me to just close the boxes, put them away, and everything is gone. It's a bit annoying that I don't have like a dedicated work area where I can just like, you know, leave the mess, because it's also very nice sometimes. But yeah, that's the cards I've been dealt. Same here, but then with my bed, just move stuff from my bed to desk and back and forth. I also have that setup. Different room. Let's see. So we have a couple of inserts here. Maybe we need to get some more inserts. Oh, you're still looking at the manual. Okay, let's just put the heatset inserts in the places they're supposed to go. And go from here Oh, that starts well. I already melted the part. Yes, it's stupid. Oh yeah, it's just a spacer. Ay, ay, ay. I did not pay attention to this one. Okay. I forgot how small the mini stealth burner is. I kind of melted the corner up here. We'll make it nice in a second. Yeah, I totally forgot that these are the annoying ones. Okay. So I don't have a lighter at hand. So usually what you can do is like you can put them on a long screw like this, use a lighter and then put them in. Because I don't have that, let me basically just use a soldering iron to heat them up. And then we just have to be quick. Let's just put this up. Let me make sure to unscrew this a little bit more and then let's just pump it full with heat. Otherwise I'll grab a lighter quickly. I think that's the quicker solution. Although conceptually it should be kind of the same. It's getting toasty. Let's give that a shot. Okay, that doesn't work. I need a lighter. Okay, let me quickly grab a lighter. Sorry. Right back. Back with a lighter. Let's try again. Let's get it nice and toasty. Nope. Oh, yeah. I feel like this was easier last time I did that, to be honest. Or the last times. Not like it's the first. Okay. Let's just maneuver it from the side. No, just want to make sure this one has enough space. Let's see. This one not quite, so we kind of have to. I feel like the normal soldering iron tip makes it easier for those like hidden ones. Because the tip is a bit longer. Makes it easier to kind of like reach in a certain sense. Then with like this tip, like it's really hard because like, it's quite short, so you have like the thick barrel quite quickly. Not perfect, but will do the job. We have those three. Then we have the idler. It's easier. In. Then we have these two spacers where the recommendation is to get like aluminium spacers, which I don't have. I actually never tried using the plastic ones, so let's just see how it goes. Alright, that went quite well. Could be worse. See if we can manage the second one. Also went well. Success. And oh, these are all the parts. Pretty sure we're missing some, but I guess it's for a later step. Oh yeah, later step. So we have 1, 2, 3 here, and 1, 2 on the bottom. That was wrong hole. Here we go. This one is also easy. And let's see, it could just work. Just works. And nothing in the center. Oh, this one could have been a bad. Oh, there's plastic inside. Wait. These inserts I mostly recycled. Shit. And this one seemingly was not properly removed. That's annoying. Because I don't think that a screw goes in normally here. Like there's just like a bit of ABS in the threads. Let's try following. Just heat the screw up and try to kind of like clear the way. Yeah, we'll be fine. We'll be fine. I think that did it. Okay. Cool. Then this part's also done. And then we have this. What's the part called? Guider. The guider has this support piece we have to break off. There we go. And basically this is already assembled for us because we used it before. So it's just drops in. Oh, and there's this M2 self-tapping screw, which I'm pretty sure I don't have at hand actually. Totally forgot about that. Let's see. I do have M2x10 normal machine screws. let's use this one. And there was also another one we need to add M2 by 6. Which should be this one. We quickly need to measure this because I think they got a little bit mixed up. Yeah, should be 6. Okay, crisis averted. Let's put it over here. So then this one goes in here. The camera is a bit far on the back. I feel like I'm always working almost out of the frame. So that is in. So basically the screw doesn't connect anything. It just like strengthens the part in this direction. Already got away. Bye Jordy, thanks for dropping in. So this is this one, and the other one is kind of hidden here. Let me actually do it like this. The Allen key I use there is not the most high quality part. It's a bit hard to drive the screw into plastic. And this screw is just like to later adjust the tension. So I don't think I ever adjusted that, to be honest. I think you mostly need it for flexible filaments, which I don't print at all, basically. Okay, so these are all the parts. There we need like M3 screw. Most likely will tell us in a later step to put it in. But here we go, that's in. So we did this already. Then the gears. So this one is adjusted for the stealth burner. So I would assume it's the same spacing. And I see we are missing the top bearing here. Let me quickly grab that. That is still hiding here. Oh. Oh, I never saw that. That's interesting. So I don't think this mark is supposed to be here. That's the motor plate, basically. And there's like some dust. Not sure if this is ABS or something else, but it's really fine. Like really fine. Thanks for dropping in, Sven. So that's interesting. Let's pay attention to this when we assemble the mini stealth burner. But for me, it seems like that the axis here is a bit too long because it pokes out on this side. And if we put the bearing on, it's not even quite. Oh. Interesting. and just, yeah, like it pokes out on both sides the shaft. So potentially this is just a tad too long. Maybe that explains partially my uneven extrusion. I just like basically drilled a hole in this plate here. I mean, it doesn't do anything, but if you compare the second motor, there's definitely no marking like that on this spot here. So interesting. So, but yeah, let's pay attention when we now put this together. So according to the manual, this is what we need to do basically. We already put in the nut here. So let's... Oh, this bearing also is not really eager to come off. Let's just use this one. Let's put this in here. A bit of a tight fit. We just used... Just using the ear of the motor to press it in on the edge of the table. That is in. But this bearing is kind of baked on here. Yeah, so something was not quite okay there. Okay, so this is prepared. And it tells us to super glue the hex nuts, which we can do. We have super glue at hand. Let's just tap a little bit here, tap a little bit there. I really prefer the super glue with the brush. I feel like I have much more control where I put it. And how much I put. Okay. Nut now super glued. Then let's see if we get this off. Like, I'm a bit concerned is the wrong word, but something is clearly not fully right with this. That's good. I replaced it on the switch wire. Just quickly fully remove that. Yeah, there's only one. Again, this is completely locked in place. Let's see. I mean, technically, we can just leave it in and work around it, I think. But it means we cannot adjust. But why is this so hard? There's no thread locker applied here. So I'm not quite sure. And I think... Let me think, is this the part from the LDO kit, from the V0 LDO kit? I think it might be. This might be the part from the LDO V0 kit. And I remember there was something with the axle not being quite up to spec. So potentially this is the explanation. This also doesn't like quite spin. There's some clicking. Okay, let's just put it together and just see how it performs. So we leave out the bearing here because it's kind of like permanently attached to the shaft. Let me put this just back together. I mean, we can. I do have some of those bearings as spares, so let me just try if I can. Yeah, this is completely on. I have no clue what happened there. Let's see if we can loosen it if we heat it up a bit. By the way, I have a fan over there. That's why I'm kind of like struggling a bit with the lighter. Oh, and the lighter's empty. Yay. Okay, let's see if this helps a bit. Okay, this is completely fused together. That's weird. Okay, we tried. Let's leave it like this. Cool. Then we add the guider in here. Shuttle it's called. Then we add the guider, which is inserted like this, and it will pivot around the screw here on the bottom. And then the latch, which then basically will actuate that mechanism here. Okay. Then we need 3 by 25 screws. Let me see. Where do I have those? And the interesting part is that they use button screws, but I only have socket head screws. So there's a button screw with the rounded top, and that's a socket head screw. So let's see if that works out. Otherwise we have to steal some screws from somewhere. Okay. So this, yeah, should work. We lost the latch. Oh, the latch is supposed to be here. Let's try this again with the latch in place. Okay. Then the second screw is basically where the latch grabs on. I feel like the turquoise parts are just like too tight from tolerance. Yeah, the socket head screws work out fine. Okay, that already clicks in place. And then there's a third one down here, which is also M3 by 25, and this one we shouldn't tighten too much. For this one, I'm skeptical if socket head will work. Yeah, like they're too tight. The blue parts are too tight. Turquoise parts. What's this? This makes quite a long impression. That's the same, okay. Screw this in here. This might be a bit problematic that it like grips already, but let's just see how it goes. Okay, and this one shouldn't be too tight, because this is like the pivot point of the guide here. Okay. Yeah, now it's the screw head like stands out a tiny bit, so potentially we need to replace this one with a socket head screw. But button head screw. Okay, let's quickly do a test fit. Yeah, that is not working. So this screw head is too tall. See it there? It's just like poking out a bit and like touching the wheel. Let me just see what we have flying around here. These are actually 25s. Fill this up and get rid of this. That's too short. It's also too short. Oh, what we can do? I have not the right length. I was thinking of using one of these, like the countersunk ones. That should also work, but I only have 22 or 28. I don't have 25 of that. No, it's this one. This one is a tad too long. But what we can do is we can shorten this a tiny bit. Let's just do that. Let's just do that. Let's make our own M3 by 25. Okay. So I don't think we need a lot lengthwise. It's always like a bit of a guess. So we need like 5 millimeters. That's a good guesstimate, I guess. Let's see how close we are. Ah, that's pretty good. It's exactly 25. Okay, let's get this one out. And get a new and improved one in. That's a bit annoying. That means for like to build this printer with this tool head, you need exactly one M3 by 25 button head. Exactly one. Because I think it's fine everywhere else except here. Okay, let's see if it now works. It's still... Oh, this is not on properly. Let's see. Why is this not on properly? Let's quickly loosen those again. This might be caused... No, actually shouldn't. I want to say it might be caused by the screws like gripping slightly in the blue material. I think it was just like, because it's quite snug, Might just not have been like all the way on. Yep. There's the screw missing. Now it's better. So let's put this back. Okay, now it's better. It's like very nice click. Okay. Then we have two M3 by 10 from the bottom. There's another question if we can use the socket head or whether we need to like cannibalize some more button heads. Although like for the M3 by 10 I should have. That's 12, so these are too long and these are 8. Let's see, but I definitely have like quite a bunch that should fit the bill. What do we have here? Ah, M3 by 10, 2 times. And this one was the one where the heatset insert was not very good. So this one will need a little bit of more force to go in. Maybe it's even good if we heat the screw a bit again. The other option would be if the let's just be quick. The other option would have been to remove the heatset insert, but chances are I'm just breaking the part. Okay. I think it should be good enough. It's roughly as far in as the other screw. That's the risk of recycling the heatset inserts, but I haven't had that happen before. So for another ones, we should quickly check if like another one has the same issue with like plastic in the threads. I think that should be good. Also kind of running the risk now to round the screw, which we don't want ideally. Okay. Then this is complete. Okay, then let's quickly see if this now all fits together. I'm still doubtful. Yeah, like this doesn't run smooth. As far as I can see, it doesn't, the top wheel doesn't touch anything. So it might just be that this is too close. But it's like I'm still like so confused why this is so baked in. I mean, worst case, we just use the other pair I have. I feel like it's moving a tiny bit. Now there's like a tiny, tiny gap. This is so weird. Let me see if I get flathead screwdriver in between there. Ideally without stabbing me. Yeah, I feel like we're getting somewhere. Let me see if I have a flatter one. And it's like issues that only happen to me. Here we go. It's a larger one. Here we go. But something tells me that the gear itself is also also locked in place. What happened here? And it's not the bearing. Like this is like super easy to get on the other side. But yeah, on this side is really tough to get on. But even if I now put this in without the bearing, something isn't quite right. I feel like that the blue part touches. Why is this blue part so wrong? So I basically feel like this like ring here touches the inside of the blue part. I don't want to push here too hard because I will dislodge the plastic here most likely. Don't know why this is so tough. It's a bit hard to see. Like if I put this in, something touches somewhere. Oh, this part is the wrong orientation. Of course. We need to get this off. So basically on the stealth burner, you need it in this orientation with the gears on top and the teeth for the filament on the bottom. But for the mini stealth burner, it needs to be flipped around. Like the gears need to be on the bottom. So we need to get this off. Okay. Then let's see what IPA does. Maybe there's some residue in there. Yeah, I'm pushing out the, yeah. It's exactly what I feared. I'm now pushing the plastic gear from this press. I'm not pushing the actual gear. So I think this is just a lost cause, to be honest. This is annoying. Because I don't know what causes this to be so stuck on here. Normally I would say like I can heat up the entire thing, but then like I definitely melt the plastic here. So I don't know how I would get this dislodged. I wonder if I kind of like hit it from the top here with a screwdriver and just hit the top of the screwdriver, or if I get this like some of this lodged. I just need something to rest that on, like this. Okay, now the white gear is back in position. Oh, and it broke. Okay, yeah, that was expectable. Okay, then this is toast. I don't know why this is so stuck. Then change of plans. We have this one. Let me quickly actually check if I have another one of the white ones, because I feel like I ordered one. We have parts. But I don't think. Yeah, I don't think I have the white here. Okay, yeah. Then let's use the black set I have, the palm gear. But I think we need them to replace both sides. I'm not quite sure if these are exactly identical. They might be, they might not be. So let's just get that out and then use the same. Okay. Let's get this out. It looks pretty much identical to me. But let's just be certain. Let's put this to its brothers. And this one needs a bit of grease. Although, to be honest, I don't think it needs, because here, this one is a bit different. This one has small ball bearings here. So I don't think this one needs grease. Also, this will be like a temporary thing. I don't have grease at hand, so let's just use it like this for now. And this one is pressed. So this one is the difference between this one and the white one is that here you had the set screw to hold this part in place, and here this is pressed. And this makes this part this part better, because basically the gears with the set screw here, I mean, in this case, it's completely baked in, so I don't think there's a difference, but usually the set screw causes this like bottom metal gear to be ever so slightly off center of the main axle. And what this does is it causes uneven extrusion, because basically depending on which like part of the rotation basically the bottom gears, a step of the extruder motor will rotate more or less filament, because like the diameter of the gear basically changes ever so slightly. And the benefit of these is basically they're pressed on, so they're perfectly centered, so you don't have that issue. And the black gear here is also more precise than the white one, so it just like overall has better extrusion basically, or more precise extrusion would be the better term. I don't know, dear. Okay, let me see. And I'll toss the bearing in there, but I think these are the same bearings. Yeah. Let me quickly. Yeah, there it is. Oh, it's bearing out. I want to do electronics, not assemble a mini stealth burner for like 5 hours. Okay, let's get the bearing in there. Oh, why is this magnetic? This is not really helpful for it to be magnetic. I think it's the Allen key is slightly magnetic. Okay, that's in. And let's put this back together with our custom-made M3x20 screw. Why didn't you go with Spartacus? You can push it with gear assembly. Not quite sure, Nadir, if I can follow you. What is Spartacus? Is that like a different gear? Oh God. Yeah, now I realize this one is pressed in place in the wrong direction, of course, as well. So this doesn't even fit the mini stealth burner. This is only for a stealth burner. Aye. Okay, then I'm out of parts. Then I have to first order the gear here. The bearing, you can push it with the beam G gear. Oh, you mean just put it in here and then push in? Yeah, I guess it also would have worked. Okay, but yeah, then we kind of like hit a roadblock here. Then I don't have any of the gears. I have to order that first. That's kind of like sad. But then I guess we cannot resume assembling this. Hey, okay, that's annoying. Let's put the thumb screw in here. Set screw. Okay, let's get it quickly out again. Then the plan stands that this one goes into the switch wire where it's supposed to be. And then I will just order a set of those extruder gears, BMG gears. So Spartacus is different gear set. I'm not familiar with that one. This one I have here, the black one, is the, I never know how to pronounce it, Physec, like the Chinese manufacturer. I heard good things about this one, so I want to try it out. I also have the Ritka from BMG. That's an EV0. It's the same thing. It's just like the press on. Spartacus is too light. Oh, I don't know. That's just a standard mini stealth burner. I didn't go for any specific tool head, but technically any tool head with the mounting for the V0 would fit. Okay, then let's kind of collect all the parts. You know what? Like let's just put it on, partly assembled, back in place. Then it's out of my way. And yeah, then all the parts, and then next time we can assemble that. Too bad. Well, now we can do electronics. It's mini stealth burner on steroids. Let's quickly check it out. I only know the dragon burner, which also was an option. It's just like for the mini stealth burner, I had all the parts. At least I thought so. Turns out I don't have all the parts. Okay, let's quickly, what kind of screw do I need here? M3x6, which I most definitely have here. It's always nice to have like random screws. Never know when you need them. Okay. The bottom two are M3x6 and M3x10. Oh. Oh, that's M3x6. Okay. We need a longer one on the other side. And this most likely M3x4. I'm always so bad at guessing screw lengths. Huh? For example, this one I could have sworn it's longer than M3x6. So if this is M3x6 and this is M3x10, this looks good. Okay. No gears. Set. Yeah, and it's also not waste time to like do the fans and stuff. I mean, technically we can put it together, right? We can still mount the motor. We can still mount the hot end. We can technically wire up everything. We can put on the tool head port. Technically we can do everything. Let's just continue. And then next time we basically just add the gears. Oh no, let's do it next time. Then we do the tool head in one go. Then let's focus now on getting the main machine moving. Okay, let's put these parts here. There's nothing to do with this build at all. Then the motor, toss that back in. Oh, it's the wrong box of chaos. Get rid of this box. Okay, there you go. And then I also have a nice little pointless box for the extruder motors. Okay. Let me quickly very basic cleanup. All the tools we don't need anymore out of my way. Let's do actually quickly mount the hot end, then that's also out of the way. I'm quite sure what I use these for. I think, yeah, here we need the M3 by 25. No wonder, I think the hot end should be the other direction. Oh wait, there's the long screws will hold that. But yeah, this one, the block needs to face forward. So this goes directly in the opposite direction. Here we go. Okay. Should it though? Because now it's really hard with the cable. Okay, that's for some other time to figure out. One of the two orientations it will be. Technically, I think it does make a difference for us whether the block faces like pokes out a bit or not. If it makes the cable routing easier, I mean, you can always kind of bend it. Yeah, should be fine. Should be fine. I mean, also like here we will have the cables of the switch. So maybe it's nicer to have the cables on the other side, but technically you can also just route the cables like that, right? Like, it's also fine. We have to extend them anyways, and crimp connectors on them. So for now, let's just put them here somehow. Okay. Then these we will need in a second. Clean up these. That's trash. That's tools to clean up. Tools to clean up. Okay. Here we go. And then we can mount that. What camera do you use for the live stream? Two cameras, or like one camera, depending how you want to count. So quickly. I can put this on and I'm all with you. Okay, well, it doesn't do much, but it has a couple more parts than before. Well, okay, cameras. This one, the front camera is just my iPhone, because I only have one camera. And this one is Sony A7C, which is a bit of like overkill, but yeah, it is what I have. And actually the lens, so it's a full frame camera, if that means something to you. But the lens I have on is a APS-C camera, so it's basically just like operating in crop mode. But this lens is really good. It's actually the kit lens of Sony, so it's quite cheap. It has like this zoom range, which is like quite good. It's like standard zoom range, but then it has a digital zoom, so I can like show stuff really like nice and close up, which is really handy. What app do you have to use the iPhone? It's just built in. I use a Mac and an iPhone, and the iPhone just shows up as a webcam on the Mac. There's no app needed. That's the Apple magic. It's actually quite cool. It works really well. And like the thingy that follows me, that's just like built in the operating system, basically. Yeah, then I also wanted to check with you the Spartacus toolhead. Let's check the Spartacus toolhead because I'm curious what this is. It's kind of funny, like I always think like I know quite a lot of like things like that. Oh, you made Spartacus toolhead. I see. So what's the difference to the mini stealth burner then? Does it use the same hardware? Yeah, it looks like the same fans, same extruder, but same part orientation here. So I will run the same problem right now. So it's bigger. Not same fans. Oh, I see. Like it's taller. And bigger fans. Okay, check. Looks cool. I think for this machine it's a bit overkill, because I don't think that flow rate will be my primary concern. It looks like really sweet toolhead. Yeah. Then what did we want to do? Yeah. So basically, my goal would be just to get some basic movement out of this machine. So we have a main board that's flashed with Clipper, and we do have some preliminary cabling that we did like last time or the time before. So we have 4 motors. We have two Z motors that we need to synchronize, and then we have A and B, and then I mean the extruder we don't have at the moment, but at some point we will. So this is just like a preliminary thing. So my goal is to make it move, so we can try out the Z movement is working, just like to test the concepts. My like wild dream was that if the toolhead was working, we could have kind of aimed for like making something print, but yeah, not gonna happen. So I also won't bother installing the bed now because yeah, if you don't have a toolhead, you don't need a bed. So I did buy some really nice cable. That's silicone cable, 24 gauge, I think. 24, 26. Don't quote me on that. And it comes in like 4 pair basically. And this is what I want to use for the final motor cables. Just like it's nicer if it's like a bundle. And I like that it's black. That's why I went with this one. It's silicone, so it's quite flexible, nice. And yeah, we can use the same for the end stops. So we can basically just like rip it in half and use it for the end stops. And potentially I would use the same for the thermistors on the bed. And then for the tool, everything is canvas anyways. And for canvas, we need to make a cable in some way, shape, or form. I'm not sure yet what we're gonna do there. Clipper magic, exactly that. And it's narrower than mini stealth burner and has 2 nozzle LD. The mini stealth burner also has 2 nozzle LD. Small ones, but they're there. Oh, you have with the acceleration. Yeah, I remember. I was not aware anymore that was you, but I remember that very well. We actually have to set this up again because due to an accident, I lost my SD card. So I don't know what happened. So seemingly I cramped it in a box, and the SD card was like poking out of the Pi Zero, and it just broke in half. Basically, the SD card was just broken. I've never seen that. I have no clue how this happens, but yeah. But this is the main board. It's Mellowfly Micro 4. It's nice and small, so this is the entire electronics basically, plus the tool head. But why I chose this board, it's small. And I really like small in this case because I don't think we will have like tons of space for electronics, so it's just easier. Just to give you an idea of how small this is. I thought this was a small board, which is the SKR Pico. But yeah, compared to the SKR Pico, it's basically more or less half the size. So it's tiny. This has like a couple of advantages. Like I originally planned using the SKR Pico here. This will be used somewhere else. Why I switched? Primarily switched is this one has native CAN bus support. So also flashed it already with the CAN bus firmware. I think it's like these 2 pins here. That's CAN high and low. So if we use a CAN bus toolhead board, we don't need any extra adapter or something. It's just this board and the toolhead board. So it's really compact. Yeah, that was like pretty cool. And it has exactly 4 drivers. We need 4 drivers. I mean, technically you could have that on the same, but if you have like both Z motors on the same driver, but if you have both Z on one driver, you cannot like rack or direct the bed basically. What I want to do later is to have the probe, to use the probe to like rack the bed between the 2 motors. Yeah. That's just kind of like roughly wired it up, I guess. I will also just have the printer maybe in this orientation, the like facing the back. You and drivers will end up with all 4. What are you implying here, Steve? I'm. What are you implying? All 4 drivers will survive. Lessons have been learned. Yeah, let me quickly see. I had a bag with maybe not even a bag, but we had like some random motor cables we can use. Because I don't want to do the final cables yet. You might need to do one. So these are 2 motors. These are the end stop cables. Let's actually just quickly wire this up. So this is one motor, two motor. I'm just randomly choosing some drivers now here. I don't think they are labeled in any way that makes it special. So we have two motors. Then, though it might not seem like this is supposed to be two end stop cables we made last time. Or the time before. My memory is blurred. Here we go. Okay, this is one. And the end stops are mounted at the moment here on Z. So we don't have end stops on X and Y. Carefully move this down because now steppers are attached. Okay. And this is actually something, now that I see it, that might be a bit problematic. That's like the things if you design in Fusion. So if I move the bed up, let me actually see if your warning was received. Let me unplug the steppers. So if I move this up here, I think what will happen, I mean, it's kind of okay, but there's like not a lot of breathing room for those cables here. So it's something we need to pay attention to a bit. So let me just, it's also something I have no clue yet how to do later. If we will have like a cable chain or something for like Z. It needs to be determined. Okay, this is one, and yeah, then you see like the other end stop is here. So they're basically just on opposite sides, so we can home both both X motors individually. And later, basically, we'll replace that with the probe. Is SEO8 any good, or you had any problems like I see most have? Didn't have any problems. I've modified mine a lot. I'm also interested, like what was your conclusion or like your resume of the SEO8? I was like low-key tempted because I saw that Teaching Tech was modifying the SEO8 to be like a tool changer, which I'm highly interested in. This is not a stepper cable. This is a really short stepper cable. But I'm not 100% certain about the polarity, so we can use this cable for one of the Zs here. Pull this out. We just need to quickly compare that these two cables have the same pinout, because I know the black one is correct. I guess this will be our last cable, so we need to crimp one. Yeah, one needs to be crimped. And this one is our preliminary power supply. Okay, then let's quickly check the cables and make sure that's all okay. I recommend SEO8 if you want to tinker a little bit. So it's not a working out of the box printer, basically. But it's an interesting part because it's open source, right? Like you can tinker. That would be my expectation. Okay, let's quickly see. So the outer cable goes to the opposite side out. Okay, so the out goes to out. And inside goes to in. Let's quickly compare this. So out, we had this one goes to out. Yeah, and in goes to in. So these seem to be wired in the same way. I'm not quite sure if we used them before, but that seems to be consistent. So these two are both fine. Yeah, that seems fine. You have to go. Thanks, Nadia, for checking in. $500 350 machine, it still needs some love to be 100% perfect. Yeah, of course, but like, I mean, for the price, it's quite a good deal, I think. That's just my understanding. Let's actually also unplug this one quickly. This one luckily has colors, so let's just crimp the connector on this one and just copy it over from these colors. Okay, let's do some crimping. Then, yeah, let's do one side first with the JST XC is the large one. Yeah. So, see you next time. See you next time. I hope I can remember all the stepper configurations. Okay, let's see if we have a good crimping day or a bad crimping day. Eight crimps to have a lot of fun. I've printed 2 rolls with no problem out of the box, but I installed a different probe and a different shroud that I've designed. Yeah, I mean, like, that's most likely what I would do as well. I just saw that like the Teaching Tech had the video about converting it into tool changer, and he uses the original tool heads, which is nice, I guess, because like you can buy them just out of the box. But yeah, it would be mine. Most likely I would tweak quite a bit. Just have to be really careful here to not pinch the other cables when crimping one. That's always a bit tricky. It's 2. Seems to be good crimping day. Hope I didn't jinx it now. And the last one. Love to help. That's great, because I need all the help I can get. Okay, that's one side crimped. Let's also quickly crimp the other side while we're at it, and then we can put it into the connector. Let's just give us a little bit more wiggle room on this side. Okay, and for this side we need the small ones, pH. And I never remember if I crimp them on the smaller setting or on the same setting. Let's try the same setting, the medium size, and I think this one I already screwed up. Here we go. Yeah, the medium size is still good. Actually, don't even. So usually what I do is I put it on, and then I use these pliers on the top. There's a flat section to like just squeeze it on a bit. Actually, still need to do that. So I position it. And just like squeeze it tiny bit on. Now I know it's in the right position, and it kind of stays there more or less. And then I can crimp it. I know everyone kind of has their own way of doing this. And that's my little way. Here we go. All crimped. Best printer I have the Thingiverse ANET A8 on its metal frame and all the printed parts using RAMS 1.4. That sounds like a really old printer that has all its little kinks and issues ironed out. It's actually, like, to be honest, for me, it's too much fun tinkering on stuff. I'm always changing stuff. Also, switch wire. Like, if I would have just left it, I just like continuously ironed out like some issues, it would have been perfect by now. But nope, I need to constantly change and tweak it. So I introduce new problems that I can then fix. But if you have an old printer and it works, like you spend all the time to find issues, optimize things, I think that's the most reliable machine you will ever have. Let's see, where is here? 6-pin. Okay. Then let's just copy exactly what we have here. So we have black, green, red, blue. Perfect. So we just need to make sure that the... Yep, you're in the wrong one. So we have... Oh, that's the wrong crimps for that. So it's exactly the opposite. Perfect. Black. I should just use the tweezers. Black, green, red, blue. Perfect, all in. Would have made sense to just turn the connector around, but hey, I came around. And then on the other side, it's blue on the outside, so that's okay. Then it's green and red twisted in the center with one pin free. And I think that's all the way in, now this. And then black on the outside. Let's do a quick tuck test on all of those. Okay. That's also okay. Cool. Then we now have all the cables we need. Everything is there, all the measurements. It's easy to build. Yeah, I mean, the A8 is also not like a complex machine by modern standards, I would say. I got FSN the other day, and I don't think you can alter them much. I have no experience with the FSN printers. So far, I only had Creality and like open source machines, like Voron. Yeah, that's it. I considered building a Prusa Mini at some point, but that never went anywhere. Okay, let's use the black and white for the Z. And then the colored cables for A and B. Oops, it's the wrong side. Okay, that's technically all the wires we should need. Let's actually just plug them in. So we have Z1, Z2. We have A and B. And now we have the two end stops. So I'm not quite sure where we need to plug them in. Oh, there's the on the bottom. It has the pin out. I assume that those two are meant to be fan ports. So I think we should. Yeah, then we need to change the connectors here because these are not 2-pin, but the end stop pins are 3-pin. I think that's how it's. I think that's how it's meant to be. Let's quickly check the manual for that thing. It's cool though that the printhead moves on pulleys. What printer is that? Mellow Fly Micro 4. The documentation of the Mellow board's a little bit weird. It's not as easy as others, I think. As mainboards. 5. Yeah, see here it's not even listed, but I know that it's there because I've looked up the docs already. English? Give me your Google Translate. Okay. Yeah, this is our board. Exactly, the firmware compilation, that's I did it already. Motherboard wiring in progress. But this is not the documentation I had before. Let's just see how they configure the end stops here. Yeah, and then they use the virtual. So this is sensorless homing already. We will use this doc. It's actually good if we found that. Let me actually just open it in a new tab to save. Position, end stop pin. They use GPIO 12. Which is GPIO 12? Yeah, it's one of the 3 pin. And they pull it high. So yeah, let's quickly change those to 3 pin. FSUN 1, 1 pin will be ground, the other the chip. You mean for the answer? Yeah. It's just like they have like the 3 pins here, so they have a ground, 5 volt, and GPIO. So you can decide whether you want to have it as a low or high, basically. Let's carefully get these out. No interest in crimping that again. Yeah, that is not really cooperating. Here we go. No, okay. 1 to recrimp. Why is normally this is easier to get out? Okay, 1 we saved. So if somebody's interested in more crimping coming up. Quick. Here we go. Okay. Yeah, we need to recrimp 1. I guess that's okay result. Let's quickly use a knife to drop the little like how do you call them, latches back up. Okay. Yeah, it doesn't really matter. So basically they pull in the center config, they pulled high. So they should be on this one. No, it's just make sure they have 2 of the same cable. Now that we connect them over cross. Okay, these 2, let me just like put them over here. Yeah, okay. And then these two are 1, and here we need to quickly crimp new connector on. And just to double check, yeah, that is correct. Quickly crimp connector there. FLSUN 1. Okay, let me quickly look this up. I need a new motherboard for my Ender 5 Plus 3D printer. What do you suggest and what firmware should I pair with it? If you have a Ender 5, I assume they use the standard Creality mainboards. That would be my assumption. So I would look for anything with E3 in the name. I don't think there's a huge difference. So what I personally used a couple of times is the SKR Mini E3 V3. That's kind of like a standard choice. Just double check, but the hole pattern here should match perfectly your mainboard. And this has everything you need basically. This is a drop-in replacement basically for your mainboard. For firmware, you can either go with Marlin. That might be the easiest. So if you don't want to change a lot, you can just use that and use Marlin, and it's basically the same as before. If you already have a Raspberry connected to your printer, you can also use Clipper. But yeah, that depends a bit. If you have a Raspberry lying around, you want to try Clipper, you can try Clipper. Otherwise, I would just stick with Marlin. This board, but there are like quite a lot of different ones. And all the E3 basically is the Ender 3. There are quite a lot of like replacement boards for the Ender 3. And yeah, so they should fit 1-to-1 in the Ender 5. I'm 99% sure that this is the same mainboard. So that would be my recommendation. And it's a quite a upgrade over the Creality mainboard, I would say. Oh, no, I still didn't look up the FLSUN 1. Let me crimp this connector and I'll check that out. Still use Marlin with Octopus, which is perfectly fine. The only reason, I mean, Clipper is cool, don't get me wrong, but in daily life, I don't think it's a huge difference. The benefit I see with Clipper is if you have like more fancy printer, let's put it like this, you have a bit more options. So, for example, you can have that was not a good crimp. For example, you can have multiple mainboards, which you cannot have with Marlin, as of my knowledge. And that's actually quite an important thing for me to have, because all my printers have more than one mainboard. This machine will have a toolhead board and the mainboard. The V0 has, let me actually quickly shorten it. The V0 has 2 boards. The switch wire has 3, I think. So yeah, it's like a bit more flexible, but I think like for the daily use, it is the same. And Clipper is definitely harder to set up. There's definitely like a steeper learning curve. Because like for the SKR Mini, for the board I just showed, there are pre-compiled Marlin firmwares. Potentially it just comes pre-flashed with Marlin. So it's really easy. It's a FLSUN QQS Pro. Let me quickly let's leave this tab open. We need it. FLSUN QQS Pro. Oh, it's Delta. Yeah, that's Delta is cool. Delta is cool. The only downside is like it's super tall and like your build area is quite limited. But Delta is cool. I think print quality wise, Delta is still the best. You have the least artifacts. Okay, that's one. Let's quickly do the other one. See if I get it right. That's the top one here. Okay, perfect. And then they have it. We'll look for an E3. Yeah, I mean, like the SKR Mini E3 is the one I have experience with. So this board here, for example, is from Mellow. They also have E3 boards. Yeah, see here, Fly E3 series boards. It's just like they all called them E3, which makes sense. So here you have Fly E3 V2. What's the difference in here is this one, for example, has CAN bus, if that's important for you. Something the SKR Mini has not. So you can just compare a little bit like what kind of features they have. So maybe some have like some connectors you want to use, for example, CAN bus or something like that. If you don't know what this is, you don't need it. That's kind of like the golden rule. They do it on 12. Okay. That's kind of the golden rule. Generally, I would also recommend just check out the documentation. So do you, for example, like if you're not super experienced, you find somebody on YouTube who installs the mainboard or something. That might also be like a good way of deciding which one to get. Just like see how good the documentation is. Or if they're like, yeah, people on YouTube using this exact board, then you can kind of like work along. Okay, that's quite a lot of cable here. But this should be it for now. So let's give this power. And this is kind of like a don't do this at home situation. It's not horrible. So basically we have a power supply. This is LRS 15024, so it's 24 volt, 150 watt. I kind of like put a cable on here. Yeah, don't do this at home, please. It's not perfect. It's fine, but not perfect. Let's put it like this. Okay. I wonder whether we want to have longer cables here. Just like from like an organization standpoint, but I think it's fine. Yeah, let's put some longer cables here, just like to make our life easier. Still have. Let's just. CAN bus would be fun. Yeah, like if you have other CAN bus devices, then yeah. Or if you plan to get other CAN bus devices. Let's just do it like this. I mean, this one here also operates as CAN bus. So that's something I didn't do before actually. So there's like different firmwares basically you can flash more or less. And I flashed the CAN bus one. And let me quickly finish the cables. Then we can turn it on and I just show you. It's quite cool. Then basically if you use, but then you need to use Clipper. That's just the conclusion then basically, because Marlin is not capable of using CAN bus. But you can also just start with Marlin, and then like if you feel at some point like you want to upgrade something, you can do the CAN bus conversion basically at this point. I want to make a laser engraver or to make PCBs. Have you ever built one? No, I don't have any experience with laser engravers. I thought about getting one at some point, but I don't have a dedicated space for it. So I would need to have it in my living room. And I decided that I don't want to have it in my living room because of the implications on air quality and stuff. So for me, no laser engraver. That's also the reason, like, I thought about getting words. Where are my words? I thought about getting a resin printer, but for the same reason, I decided not to. Okay, so this is the power, and then plus is on the outside. Let's just make sure all the strains go in. For like a proper setup, I would like crimp the cable thingies on the end. But now for testing, this should be plenty. For a laser engraver, you can just check if you get like a used Ender 3 or something. I'm remembering that there are let me see. I remember that there are like tool head replacements basically that you can add a like a laser to. The problem is just you need to be really careful with lasers that are unenclosed. So keep that in mind. You should not lose your eyesight over some PCB. Let me think. Because I don't want to plug this in yet. I mean, I can plug it in. I have a switch back here, so I plug this in. There's no power on it. Just kind of try to organize it in some way. This. Good. Okay. Then all the cable is here. And then we have the Raspberry, and I think I'm always very careful with connecting anything to my laptop. Where can I now steal power? So basically, I want to turn this back there on and off to start and stop, basically. So I cannot connect the, just for you to see. So I have this like extension thingy there. And that's now where the PSU is plugged in. So I can flip the switch to turn this on and off. The power supply is 150 watts. It's basically the same power supply that is recommended with the V0 from the BOM. It's a Meanwell LRS 150-24. So 24 volts, 150 watts. So I think what I will do, I will quickly plug this in. There's another like extension thingy under the table. So I'll quickly go on the table, plug this in, and then I'm right back. Give me like 20 seconds. Okay, even easier. Just plugged it in there. And that now powers the Pi, and we already have power on the main board from the USB. I have a Voxel Lab liquid printer. What is a Voxel Lab liquid printer? Like so many things I hear for the first time today. What is that different? It looks like a normal printer to me. Not sure if there's something fancy about it. If I would have been smart, I would remember the host name of that thing. Mainsail.local. So that's good. Okay, so this is our Clipper install. It's 100% blank. There's nothing on here. This is the config. So there's literally nothing. Oh, resin printer. Okay, yeah. I don't know, like the resin stuff. I think it's really cool for like small parts, like gears and stuff. I think it's quite cool. But I feel like for technical projects, resin is not as useful as FDM. Okay. I don't want to have like a config to copy in here. I kind of want to go through because it's like a unique machine. So I feel like it would be more hassle to like copy something in and then adapt it. So let's just, yeah, start kinematics. That's core XY. That's quite easy. I think we can copy the stepper X and Y from here. I think that's relatively safe. So let's copy stepper X and Y. Oh, and also copied Z now. Okay. Direction, not concerned yet. We figured it out before, but I lost the data, so too bad. This is already configured for the virtual end stop, which means most likely we need to set a jumper there. We also need to figure out which one this is. So this is now at GPIO 6, which step GPIO 6. So this one is the outermost one here, which is actually connected to one of these. And the Y stepper is at GPIO 1 and 0. Okay, so the two with the colored ones accidentally are the X and Y, which is perfect. So the other two are Z. Let's ignore the other two for now. Potentially we need to swap the two steppers later. But yeah, it shouldn't matter. So for now, let's just keep that. We don't need the comments here. Let's just leave everything as is. We need to set micro steps again and everything, but let's do it step by step. Okay, so that means we have X and Y set up, and technically it should be already good. We need to set the jumper. Which is a to-do. let's just, from my previous experiences with mainboards, let's just assume we need to set the jumper here and there. And the nice people from Mello also give us a jumper. Oh, we should also maybe set the... by the way, who asked for a mainboard? Somebody asked for a mainboard, right? Wire 54321. That's one example here, right? So basically now we don't have any documentation on the wiring. So this would be, for example, maybe not the best mainboard for your first time swapping out mainboards. Because documentation is just not really good. Okay, we have 4 heatsinks and 2 jumpers. Let's see. So I unplug this quickly. Clipper will not be happy, but then we can kind of work here without power. So let's add a jumper here. So this should be the sensor's homing jumper. Here. And then let's just quickly glue the little heat sinks on. Okay, let me actually use tweezers for that because it's a bit hard to reach. But at least the heat sinks won't fall off all the time because they're kind of like protected from all sides. Cool. Okay. Then this is done. I want to make a DIY Core XY printer with V6 hot end Big 3 type PTT SKR V.4 controller, TMC24 and separate drivers, etc. How many watts would the power supply be? It mainly depends on your hot end and on your bed. That's always the main concern, right? So let's say like all your electronic thingies, 5 to 10 watts max. That's already like quite generous. The motors, it depends how much amps you give on the motors, right? So on 24 volts, let's say you drive each motor with 1 amp. It doesn't quite work that way with steppers, but let's say you need yeah, I think half-ish wattage what you put on amps. I never figured it quite out. So let's just say you need for your motors in total maybe like 50 watts. So then you're like at 60 watts, let it be 75. And then the question is how much wattage is your hot end and how much wattage is your bed? Because these two are the main culprits of power consumption. The typical hot end pulls 40 watts. And the typical bed depends on the size, right? So this machine has a 150 watt power supply. I just went with that because that's what comes with the Prusa Mini, and that's the Prusa Mini bed. Might be a little bit on the edge because I have 1 extra motor, but should be generally fine. But for example, the Ender 3 comes with a 350 watt power supply. And the Ender 3 has the same motors setup basically. I mean, if you have one of the more premium versions, you also have two Z motors. But it has the bigger bat, and the bat pulls, don't quote me on this, but I think like 200 watts. So for the Ender 3, the bat is the main power draw. So it really depends. So for the motors and electronics, I would calculate like 75 watts, and then take that, add the wattage of the bat, and add the wattage of the heater, and then you're fine. The other thing you could consider is if you stagger the heating. So let's say like you first heat your bat and then you heat your hot end. You will more or less prevent both of them being at 100% heating at the same time. So you can kind of like back the power supply down a bit if you do that. Yeah, I think that's kind of like the... yeah, look at the part descriptions, look it up. I'm planning to use a 350 by 350 bat. If you use a 350 by 350 bat, I would most likely advise you to go with AC. You potentially might just struggle to find DC bats in that range anyways. Also, Dave, consider if you use a PC power supply, PCs use 12 volts, right? You typically for a modern printer want 24 volts. You can run all the printer components with 12 volts, but if you have the lower voltage, the amperage will double. So if you want to have, let's say like a 40 watt heater at 12 volt, you will have roughly 4 amps, right? But at 24 volt, you have 2 amps. So you have half the amperage. So your cables can be thinner. In general, it's just nicer to have lower amps. Yeah, so I would not recommend using a PC power supply, especially not if you want to have a 350 millimeter bat. If you want to build a printer like this, what I would recommend is look at other printers in this category. So for 350, for example, look at the Voron 2.4 and just check out what they use for their specs, for their hardware. The Voron 2.4, I think, also uses like a 150 watt power supply or something. But, and that's a big but, it uses AC bat. So the heat bat comes not from the power supply, it comes directly from the wall. 250, yeah, 250 watts. So yeah, I mean the 2.4 has a lot of motors, so 250. But generally, I would stay away from PC power supplies unless you're like on a really tight budget. And for 350, definitely AC bat. Uh, 480 watt is enough, depending what you want to power with that. It always depends, right? If you want to have a 350 by 350 DC bat from the power supply, it might not be enough. Well, it depends what you want to power with that, right? So the main question is if the bat is AC or not. If the bat is AC, 24 volt, 10 amps is enough. If the bat is DC, which I highly recommend staying away from, it's not enough. Okay, where were we? So we copied everything over. We plugged the jumpers. Let me get this back up and running and make Clipper happy again. Where were we? Here we are. Okay, so we have X and Y. Let's check Z. So we have two more steppers here. This one has step at GPIO 25. Is that correct? No. Oh, funny. They have a typo. they have GPIO25 twice here. It's GPIO25 for step and GPIO25 for direction. Okay, so this one is the Z1, and now we need to configure the second Z. Funny. Okay, let me just duplicate that entire shebang. And let's quickly check how Clipper wants to have two Zep steppers. Clipper to Zep stepper. Clipper dual Z stepper config. We find a dual. It's dual carriage. Stepper Z1, multi-stepper access. Okay, so we just have then stepper Z and stepper Z1. Let's call it stepper Z1 then. Then let's quickly check. I hope they don't have more typos here. So the step is 23. The direction pin is 22. The enable pin is 24. The rotation distance is the same. And the end stop pin, oh, that's something we need to figure out now. Would be 13, I guess. We just need to see. So the white cable goes to this side. Let me see. Which end stop? Yeah, they're inverted. So this is this end stop, and this is this end stop, and then you are GPIO 13, and then UART pin is GPIO 9, and UART address is 3. So this is 3, and then the rest should be the same. The run current, I would put down for that. Let's just put that to 0.5. And also here, let's put the run current a little bit down for now. Is it possible to make a custom 350 heater bed at home? I saw a video by Chronic Mechatronic where he made a custom heater bed. I'm the wrong person to ask that. I guess you can if you have the tools. But to be honest, I think it might be cheaper to just get it online. Because it's quite a common part in a certain sense. Okay, so this should be all the steppers. And we should have all the end stops. So let's just save and restart and see what it does. GPIO 13 used multiple times. That's very sad. Wait, machine. Where do we have that? Separate X diag pin. Oh. So the 13 is used as an end stop for X. And here we have 14 is also used. So we need to put this on 15. And then this one is, it's not easy. We need to see. Potentially I swap the end stops now. Stepper Z1 is this one. It's really not easy with the cable mess. No, this is 15. This is correct. Okay. Then, so basically, those two ports here, those two, cannot be used because those pins are wired for the sensorless homing. Basically, they're connected with the jumpers here. Position end stop is not a valid section for the stepper Z1. Okay. So the position end stop, I assume we just need to remove the position ones. Homing speed is not valid. Okay. I assume we need to like remove all those special fields here. You can make any size, shape, but you will have to find the nearest heater element to fit the project. Yeah. You cannot cut the heater elements. But for 350 by 350, you should find plenty. Okay, cool. So this kind of should do something. Let me turn it so we have it how it should be. So, yeah, well, here goes nothing, right? Let me just, we need to figure out again, like the directions and everything. The cables should be correct because we used the cables before. So let's just, let's do the following. There's a force move feature here we can enable. Enabled through, I think this is like this. I always forget. We have the Clipper configuration reference open, so let's just quickly check. Enable underscore force move, yeah. Like this. Save restart. Now we have the force move feature enabled. Now we can set kinematic position X 90, Y 90. 90 is just arbitrary. It's just like the center, more or less. Now you see like we are suddenly homed. So what we can do now is we can move in certain directions. So let's move X. And we immediately go to shutdown. That's good. Oh, would we need power to move the steppers? Maybe. That would have made sense, right? Stefan, stepper bus. Yeah, you can also do stepper bus. I like to do the set kinematic position because then you can move the stepper. So you can see the direction it moves. It's a bit easier. But yeah, you can also do stepper bus first, I guess. Maybe I skipped the step. Let me power it on. Are you ready for magic smoke? I don't think there's magic smoke potential, but you never know. Everything worked so far. Okay, so I was just afraid you would simply home. Well, to be honest, even if you simply home, what would happen, right? Worst case, it runs in something and you have to press emergency stop. So, okay, already I can tell you it's wrong. So I do X plus and it goes to the back. And it goes really weird, like it goes horizontal more or less. Let's try Y. It does the same weird. Okay, so something is already wrong, I can tell you that much. Let's try Z. What happens with Z? Okay, Z moves, one stepper moves up, one stepper moves down. And they also don't seem to turn the same amount, to be honest. Let's first fix that. I think that's easy. So let's check that. So the direction pin should be inverted for 1. My gut feeling says the direction of the main stepper Z should be inverted. Let's just do save and restart and see what that does. Okay, so I'm just maybe a bit tight. It's a bit crooked now. I don't think I can maybe change it. Okay, so if I move up now, we move in the wrong direction. So we invert the wrong one. So let's invert both. So the Z1 is inverted and this is inverted. More funnily, the rotation distance is different. Oh, we never configured the pins for Z1. Okay, that was not a deal. Let's try that again. You saved the config from the other SD card before it broke. For the separate, did I save that? I'm not sure if I was smart enough to save that. If I saved that, it should be in my download folder. Unless it was some temporary thing I copied somewhere. And I fear it was some temporary thing I copied somewhere. Let's do that first. I'll take a deep dive into my download folder, see if you might be correct. Okay, let's try again. Suddenly they move in the same. Okay, that's good. Then let's quickly see if we can home that. That would be tremendously cool. So the position end stop is at 105. So I have no clue what that would be. Let's just set it to 200 or something, which is like way out of range. And then just see how far we can move up. Roughly. No precise answer. So this should be 200. Let's quickly check the end stops, that the end stops are working. So we have the end stops, we can query them. So everything's open right now. So I now press one end stop. And then end stop Z1 is triggered. I press the other end stop. And the other end stop is triggered. So I think we should be able to home that. I will use my fingers to do that. Okay, so it triggers, it's good. It just like now it's completely crooked. So let's just fix it, I guess. Can I somewhat level it out? Beautiful. Oh, I need to. Okay, let's see. Let's set this as the topmost for now. So it's 58. We set 200, right? So it's 200 minus 58. So it's 142. Let's just set 142 then for now. Position max 142 and end stop is at 142. Then here I saw position max is 120. That's actually 180 for us. Let's just do 175 because I assume we lost a couple of millimeters. And the same for X. Actually, for X, we can do 180 and 180 for Y. Cool. We still need to figure out it's moving in the wrong direction for X and Y, so we need to figure that out again. How much did you spend on this printer? I have no clue, to be honest. It's partially just parts I had lying around. And then it's also not quite straightforward for me, right? Like I'm designing this, so you buy things that you don't end up needing. You buy things twice. Yeah, it's not the most efficient way. I wouldn't calculate that. It's roughly 250 euros, I would guess. Roughly. But that does mean I'm not even certain this will be printing anything in any acceptable way. So it's mainly for the fun of building it. Okay, so back to this conundrum we had here with the stackers. Because Steve, I think we had the same stuff before, like the seems like something we had before. But I can't remember what the problem was. Let's just invert the direction of X and just see what happens. The problem is like it doesn't move clearly in one direction. So the Voron getting started guide is not helpful for us. I assume that we have a cabling issue. Are you coming back? I assume we have a cabling issue. Which would be odd because we used the same cable. I'm pretty sure we used the same cable before. Yeah, now it kind of like killed itself. So my next step would be just to check the cables. I'm pretty sure we have a cabling issue. Although I'm sure we used the cable, so I'm not sure, but... Okay, let me just restart the Pi quickly. And in the meantime, I will drink a sip of water and we take a look at the cables. Because usually if it does something weird like this, it's a cable issue. Okay, let me reach through here and kill the power. We have 24 volt is off. Okay, then we know the Z work, right? So the Z cable, I would say, is our measuring, or like our benchmark. So this is the cable for Z. Let's compare that with the twisted wire here. Too much cable. Okay. So here, if I put it next to each other, the inner one goes, we said, to the inner one. Exactly. Here, when I put it next to each other, the inner one also goes to the inner one, which is good. Then we have the green that goes to twisted. So that's also correct, right? So the black one goes to the center up. Come on. Then opposite side. Yeah, it goes. So the cable seems correct. Yeah. So the cable seems correct. Yeah. Okay, the cable is correct. That's something. At least one cable is correct. Let's also quadruple check the cable we just made. Just to be sure. Black, green, red, blue. That's correct. And then here we have black, red, green, blue. So that's also correct. So I think the cables are fine, which is good. Which is good. Okay. Cables are fine. Then let's go back to stepper bus, actually. See what stepper bus is doing. If our Raspberry wants to cooperate here. To be sure, otherwise it's maybe the UART address. The UART address should be fine, right? It's 1234. Let's just quickly double check that. I mean, I copied something. So the UART pin is always 9, and we have 0, 1, 2, 3. So your address should be fine. Is a single stepper mode enough for Z-axis? I would not say so. I mean, depending on your design, but for 350, I would not say so. You can swap them around. I mean, if the steppers are, my problem is like it's, so if you look at the Voron getting started, so if you swap the direction, if the direction is wrong or the steppers are wrong, you still get, I mean, it doesn't really matter, we can just look at this one. You still get like a clear movement in forward, like in one direction. But right now, if I move in X or Y, I don't get a movement in one direction. I get like a weird jiggly something movement. And that's my main problem. So if I show you again quickly and do it a bit further this time. So I'm moving now, let's say 10 in one direction. So I'm moving 10 in plus X. You see, it's like, so it means something is not correct with the steppers. And also, it's always the same direction. Oh, minus works, negative minus, okay. So it just looks to me like something's wrong with the cables. That's just my diagnosis here. But I know the cables are correct. So let's do stepper bus. Stepper bus. Stepper equals stepper X. That kind of looks okay. Let's try Y. They bus very differently. This one is like very slow. Oh yeah, and the tension is very off, but that's a different topic. Let's just quickly compare. Do we have the correct things here. So the rotation distance is 40 on both. That's correct. Micro steps 32. We need to change it in a second. 200. Okay. Then we have, these are the same. Interpolate faults. Run current 0.6. Threshold GPO 13. It looks like they are the same, but they behave different, which is not clear to me yet. Why? Gantry binding. Shouldn't. Not more or less difficult to push than before. That shouldn't be the problem. But if you look at the stepper bus, so this is how X buses. It's like a very small movement. And then if you look at how Y buses, it's like a very small movement. Like it's, you can barely see it here, right? So something is different between the two. If that fixes, then need to swap 2 pins on the cables are identical. We just checked the cables, right? The cables are identical. We can swap the cables. We can swap the cables, but I guarantee you this will not change anything. Cables are swapped. Okay, I set this kinematic position. Oops. Oh, it could have turned on the power again. Can I use an old PC or a tiny client for Clipper instead of a Raspberry Pi? Yes, you can do that. Any machine running Linux can run Clipper. Okay, let's do this. What the? Okay. Stefan, I don't know what happened here. Why does swapping the cables fix that? The cables are identical. And if the steppers are swapped, it should still give... Maybe one of the cables wasn't plugged in properly? I mean, it now works. Like, it's the wrong direction, but now we can work with that. See? Like, now I have, like, clear movement in one direction. I mean, X and Y is swapped, but, you know, like, that's a small problem to fix. Me neither, not plugged in all the way, sounds right. Yeah, potentially, right? Because, like, if it's the... So here, look at the initial setup. So basically, you see here, with the stepper swapped situation, which we now had, technically, it still should give, like, a clear forward, like a, you know, like a vertical or horizontal movement, basically. Okay, let's check. So X positive moves back and Y positive moves left. X positive moves back and Y positive moves left. Yeah, now we are in this situation. Steppers are swapped, swap A and B connectors. Let's do that. Let me just quickly turn off the steppers. Cut the power. So let me just swap the connectors on the main board this time. Again, we are now in the exact same cable situation as before, just like swapped it on the main board. Fire it up. Okay. Then X positive moves forward. Y positive moves left. Now we are in this situation here. So X positive forward, Y positive left. So now we need to invert stepper B, which I guess is Y. So we now need to invert the deer pin here. So we change the direction. Actually, we had a diagonal movement, which means that one motor wasn't spinning correctly. Yeah, exactly. That's what I mean. Like, if both motors work correctly, no matter how you swap them and like the direction is wrong, it always is like a cross movement. But the bus on this one was way smaller than on this one. So I think there was something wrong with the cable here on this one. The document's awesome. Yeah, I fully agree. This is such a lifesaver. Like, just imagine you need to figure this out. Like, oh, I couldn't. So Y. Okay, Y positive forward, X to the left. Now both are inverted. Okay, step by step, we're getting closer. So now both are inverted. So we invert stepper X and we invert stepper Y. Okay, let's see. X moves to the right. Y moves to the back. We managed. Okay, now the question is, can we home? It's sensorless homing, so I'm always like a little iffy. So what do we have here? I mean, strength 80 is reasonable, I guess. So all goes or nothing? All for nothing? How do you say that? Let's do X, and I have my... Let's do X, yeah. Quite impact, but it's homed. Yeah, it's a bit too strong, like it's completely skipped. We can change that. So the driver strength 255 is more sensitive, if I remember correctly. So let's just put this to 100. Carefully move that a little bit off. And let's home X. That's better. Y is still quite a bump. So let's set that to 120. Pico 1. Control bars cost the same here, around 2,600 rupee. Should I go with the 1.4 with Marlin or the Pico with an old PC running Clipper? What is the SKR 1.4? It depends really what you want to do, right? So the benefit of the SKR 1.4 is you have to... The steppers are separate. So if you kill a stepper, I'm an expert in that, you can swap out the stepper. With the Pico you said, yeah, the Pico, the steppers are soldered on. So yeah, but you can also go with the Pico and Marlin, right? You can, there's no reason. Like both of them can run Clipper. Yeah, it's a question. Like they're also like the bundle here, right? They're about the same actually. The Pico is also 30-ish. I think the Pico is a bit cheaper. You get it in AliExpress for like 25 sometimes. Okay, so it's still like quite an impact that it skips here. So I wonder why it's so hard on Y. Let's do driver strength, just like 160, which is quite sensitive, I think. How's it feel called? Just want to quickly double check. I'm doing the right thing. That's not helpful. Okay, let's quickly try this again in Y. And now it's too sensitive. Start at 200, come down. Yeah, I mean 160 now didn't work. Ah, that seems now good. Yeah, sorry. No clue where that come from. Yeah, it's the I rather sometimes go too hard than too soft, because if you are going too soft, you get like reliability issues. Yeah, I mean here could also be part of the issue that the tension is definitely completely off. Let's quickly fix the tension, maybe. Yeah. Tension, what's that? Tension? Oh no, I'm tensioning the wrong one. Oh. That's just tension for 2. Just like, oh, that's maybe tension without the motors being on. That helps tremendously. That's just tension for 2. If I manage to hit 2. Sometimes I think this tool is trolling me. Okay, here we go. 2. Let's try the other one, which is way too much. Well, not way too much, but okay. Now they're like roughly a 2 both. That might also solve the issue with the homing. Let's just try X. That seems good. Let's try Z. It's a fully home printer. Just for fun. Let's just do all. That's something. Really cool. Can the Pico work standalone? Yeah, of course, the Pico can work standalone. You can use Marlin with the Pico. There's nothing stopping you from that. X is still too strong, you think? What do we have on X? I mean, let's try the same 140, right? I feel like X is a bit harder to move. That most likely has to do with the random tension we put on the screws. I have to change the parts. You also see here like there's a massive gap. So it's just like depending on how tight I tension it, like the resistance completely changes. So yeah, we can home. If we now would have a bed and a nozzle, you know, we could print, but you can't have it all. Congrats. Thanks, Stefan. Cool. I wonder whether we can upload some basic G code without any extrusion. Maybe. Why did you choose belts instead of the belts instead of screws? So the basic idea of this printer was to keep the costs low. And the belts allow me to use the same parts as for AB, for X and Y, right? So it's the same belts, it's the same idlers, it's all the parts are the same. There's no extra parts you need to build that Z, basically. Also here down the only extra part you need is like the longer shaft here. But besides that, all the parts are exactly the same. Oh, let's tune the micro steps and stuff. We had it last time. And then we lost all the data. I remember we had micro steps, interpolate faults already there. Micro steps we had at 128. Let's just do it for all. And then we use the speed test macro to move the printer a bit. You can go for, yeah, exactly, Stefan. Got you, I see why not. Yeah, it's just like to keep it simple. But also, I think it's a better system, to be honest, with the belts. Because the belt, we have 2 motors, right? But we have belts on all corners. And that was something I struggled quite a bit with to figure out how to do the bed in a way that it's working correctly. So if you use screws and you want to move the entire bed, you either need like a really, really stiff bed, and then you get away, for example, with 1 screw in the back, technically. But I cannot build like a super stiff bed from those like rods and printed parts. I don't think this will work. And then you can do like weird shit with like 1 screw in the back, 1 in the front. Ideally, you would have 3 screws, right? But then you need 3 motors. With 3 motors, you need like special main boards again. And then like you need 3 motors and 3 screws. So like the costs just add up. And this just allows us to have 2 motors and 2 belts. You can optimize this one a little bit more. Like you can maybe get rid of like some of the pulleys. That might be something for the future, potentially. But yeah, then you're really like optimizing like 1, 2, 3, 4 euros to like save like a couple of those pulleys. So generally, I think it's not the best, but close to optimum. Because like, here really now, like this is supported on all 4 corners. So that's as stable as it gets. Speed test, macro, copy raw file, copied. Let me just create a new file. macros.cfg. Macros, let's just plop that here, save. And then printer, we say include macros, save. How would the resolution on the Z be just the same as screws? Yeah, it's the same. Like it's the same stepper, right? The resolution is actually really good in this setup because you have here the. I'm not sure if you can see that. I can kind of like try to zoom in a bit. So you have the small pulley here, right? Which has 20 teeth, and the big one has 56 something, I think. So you have like a 1:2 gear ratio, basically. So each step here results in half a step actually being moved. So the resolution is really fine. So that's giving it strength, of course, because like technically the bat can be relatively heavy, but also it gives it resolution. This is, by the way, the same setup basically that the Voron 2.4 has. The Voron 2.4 has 4 motors. That's the big difference. So it has 1 motor per corner, but it has the same gearing setup. And they use not the printed part here, but yeah, shouldn't make too much difference. So that's the same setup as 2.4 basically. The only thing is like that I have 2 belts on, like technically 4, like 1, 2, 3, 4 on 1 motor. And the benefit of the 4 motors of the 2.4 is you have 4 motors and you can do the quad gantry leveling. So basically you can probe the bed in 4 spots and the motors can like level out the bed completely. That's not possible with this one, so we still need to have the bed screws to adjust it. What we can later do is like we can level left, right, but the bed still needs to be level manually basically. Yes, so we now changed the micro steps and we changed the, we added the speed test macro. Okay, then let me quickly copy the invocation because I always forget that. Let's just start really slow. So let's just say speed 100, Excel is 1000. Let's just do that. Maybe not 50 iterations, but maybe 1. Just to give that a shot. You have worked out well. Well, I got inspiration. Yeah, and that's the same, like you can most likely not hear it. Let me actually disable the noise suppression for this one. Let me... Is the noise suppression on? Yeah, it is. Okay, now the noise suppression is off, so you can hear the machine better. So basically the movements in the 45-degree directions are very silent, but like we have a little bit of vibration in the X and Y movement. And it's the same what we had before. You have worked out well. Yeah, so basically what I want to say here, this is my first attempt on designing a printer and I'm not an engineer. So what I try to do is like I try to use things that I know work. So the AB belts are roughly the same what the Voron Zero uses. And the setup here with the Z, with the 4 belts and 2 motors, is somewhat similar to the RC150 printer, I think. I think it was the RC150. The only difference is the RC150 has the motors in the center and then has like basically 2 L-shaped belt runs, and I have the motors in the back and have 1 vertical and then 1 L-shaped. So it's a bit simpler, I guess. But that's where I got this from. Okay, so this worked well. Let's actually, there was some other setting with the stepper. We did not only do the micro steps, there was something else. Let me quickly see what options we have here. We have the run current. I don't think we did anything of that. Diagram. So no, I don't think we did anything of those. Let's see, stepper X. Stepper X. So step pin, gear pin, enable pin, rotation distance, micro steps, gear ratio, step pulse duration, position max, homing speed, homing positive gear. No, I think nothing rings the bell. All you did was turn off stealth chop and 128. That's what we did? Okay, then let's... Because there was also the interpolate faults, but I think that's just like more or less the default, right? I mean, I have it on video, so I can look it up. I will do some research. But I think it was just that. Okay, let's do speed 300 and let's do it step by step. Let's do 200, acceleration 3000, something like that. I mean, I'm already so happy that like it just moves in general. That did not work. Timer too close. Aha. This indicates the host computer is overloaded. Check for other processes consuming extensive CPU time, high swap usage, disk errors, overheating, unstable voltage, or similar system problems. Interesting. I mean, it's a Pi 0, so no clue, but it looks okay for me. Weird. It's the first time I ever have an overload. I had this issue when going with too high micro steps and fast movements. That could be. But I'm fairly certain we did that before with this machine. And this Raspberry. Let's see if it happens again. Yeah. Weird. Oh, you know what? Now it's 4 steppers. Before it was only 2. Because I also set X to 128 microsteps. Where we did that before, we only had AB. We didn't have Z. So let's drop it down to 16 again. Was 16? I think it was 16. If not, we now make it 16. So the Z are not, because now we basically only have 2 steppers with high microsteps. That would indicate a Raspberry Pi 4 would be maybe in order. Why did you go for 128 microsteps? Because that was the value we tried out. So we had this running before, like at the we had this running before, before we built the base. So when it was only the top part, basically, like only this section, basically, and we configured that all with a different mainboard. Back then we used this old SKR E3 V2 or something, By the way, this one has blown steppers, so this is not suitable to be used anymore, really. And we figured out the XY movement. But then we tested out that 128 microsteps gave the best results. Because basically what happened with lower microsteps is that we had like massive vibration when doing this X movement. Which, by the way, we can try out if that's still the case. But generally, higher microsteps means less torque, but also like lower noise. Let's just drop that to 32. By the way, you should hear the machine now, right? Because I turned off the noise suppression. Actually, it's quite good now. Most likely the frame is now much stiffer because we have the under stuff. Like before it was like horribly loud moving necks. So maybe we don't even need 32. Stefan, thanks for challenging me. Let's just try 64 and see if that's good enough, because then we have a bit of headroom with the load. Use RAMs a lot. You just pull the stepper drivers and replace. Yeah, that's the thing. That's actually like one of the reasons, like I always had these kind of boards with the soldered stepper drivers. You actually see like I desoldered this one here. I have a video where I tried to replace it. And I bought like replacement steppers and I tried to solder them back on, but it didn't work. Clear skill problem on my end. But yeah, so if I now buy a main board, replaceable steppers are definitely on my checklist. This one, it's super cheap. Like this is a 20 euro board, and it's small, and I wanted to have a small board, so that's why I kind of like accepted it here. But if I buy a bigger board, it's definitely like steppers that are replaceable. Okay, that's 64 microsteps now. It's actually like very quiet. Very quiet. I'm quite surprised. Like we don't use like a lot of amps at the moment. It's only 0.6 amps, right? And the Z movement is quite quick actually. M4P and M8P for the replace steppers and the CB1 to run Clipper on the Pi. Yeah, I'm actually like the M4P. I'm not gonna do it. But see if we discussed it, right? Like I was kind of like looking low-key into upgrading the switch wire to 48 volts. And then I would have gone for the M4P. Like I think it's a really, really cool board. Let's up that to 300 and 5,000. Let's see what happens. I asked ChatGPT to compare the Pico and SKR 1.4. It said the Pico doesn't work standalone. So can you please confirm this? Oh, now we maybe should not use that speed on Z. It's using RAM 1.4. You should plug it into the Arduino Mega and Flash with Marlin. It's as cheap as you get. RAM 1.4, yeah. It's just the Arduino, right? So I'm not quite sure why ChatGPT would say that. What do you mean by standalone? By standalone you mean Marlin, right? You just run Marlin. Aha, okay. Mystery solved. Okay, ChatGPT is correct. You can... I mean, that's correct. You can always go to Marlin and then you go to where are the sample configurations. And then you can just go to config examples and then you look for your board here. So it's the Marlin firmware configurations repository. And then you just look for the samples and then you can see if it's there or not. So here we would need big tree BTT. Big tree. Where would it be? BQ. No. BQ? No. I'm not blind. Okay, I don't find big tree tech here. Yes, split the configuration up. Yeah, but like it should be here, right? Okay, but yeah. So basically, if the RP2040, which is the chip, is not supported by Marlin, then you are a bit out of luck. But it's really weird that they don't support it because like a lot of boards used it. PR 2024. I think that's what I had open, right? PR 2420. Yeah, it's okay. But then I would say then JetGPT is correct. That is what I would read from that. I'm not in the main repo. Okay, yeah, it's okay. You can also post the link, by the way. So we need to limit the speed. Can I exclude that here, please? Is there any mention of that? Like, now the problem is like the bed moves up as quickly as the rest of the machine, which is not quite. Maybe we need to set max velocity Z, I don't know, 150. And max axle Z maybe, I don't know, 500. Let's try that. YouTube stopped links? I'm not sure. Does YouTube stop links? In the yeah, you can limit Z speed in printer form. Yeah, the question is just if it's like if the speed test macro picks it up. Max velocity. It's Z underscore velocity. I have it in the wrong. Max Z. Oops. Max Z axle. And max Z velocity. Save and restart. My link did not go through. Oh, okay. Is that something I can enable? No. Too bad. No, I can't do that. Okay, then let me check Marlin, GitHub. Marlin firmware Marlin, and then it's pull request. Let's just open any, and you say 24042. Support for RP2040 and PTT SKR Pico. I mean, it's quite a process. 2 years ago it started. And I mean, still being worked on, so. It's also interesting that they now talk about CAN connections. Does Marlin support CAN? It doesn't seem like yet. Yeah, but yeah, then it's ongoing, but like quite a long process then. Okay, let's see. So if we now do this again, maybe we have the bed not doing crazy stuff. No, it's still like the bed still tries to move up at the same speed. So it overrides that. I think the problem is that the bed is at the lowest position. So if you move the bed to 10 or something, and then do that, it will be fine. But then it homes again. Is there something that we can, like after homing, move the bed up without overriding the clipper? Move bed up after home. Okay. I don't want to do like homing overrides now. Then I guess we just accept that the bed is doing crazy stuff. So that works with 5,000. So I think we're pretty good here. Like, let's just do one last attempt with like 10,500, which most likely doesn't work. It's quite a big jump. We see the link in our chat, but YouTube is stopping it from going public if we send a link. Yeah, okay. Yeah, that could be. Sounds like a YouTube thing. So the bed will like freak out again. Okay, now we also have here. So that's too much. But I think then at the moment, like we're running it at 0.6 amps, the motors. So then basically we would need to up the amperage of the motors, and then we need to actively cool the board and everything. Basically every board supports Clipper. It would be more than surprising if the SKR 1.4 does not support Clipper. I mean, there's a config for that. I don't know what the difference between the turbo and the normal one is. But it would be very weird if it would not support that. Restart it. That's something you would need to research, but I'm pretty sure it should work, unless it has like a really exotic chip or something. Cool. But yeah, then that kind of works. We have movement. So technically next time, so I will order now the part we're missing. And then next time what we can technically do is we can build the tool head. we can mount the bed in like a preliminary fashion, right? We still have the problem that if we kind of throw the bed in here, that it kind of works somewhat, but it's not quite good to say it in weird words. So basically we needed to like flip those mounts around. I'm not gonna print them again, but this way we can mount the board. At the board, we can mount the bed just using the normal yellow screws, and I don't have like a fitting screw at hand right now, I think, but yeah, so we can basically mount it here. We will need one more of these basically here in the front, and then the front one has two more of these, one here, and then we can basically mount it on the center one and left and right, and then we have a bed. So if we next time basically finish up the hot end and we mount the bed in this like very preliminary fashion, so we already last time decided that we would redesign these corner pieces for the bed so that the bed mounts directly to these corner pieces. If we do that, we can print, right? Then we have everything. We have a bed, we have a tool head, we can move, so I would assume we can print something. And I don't think like a lot is missing, right? So we only need to assemble the tool head. What we need to do is we need to flash. I will prepare that. How about we quickly whip up a canvas cable? Where is here? I would rather run Clipper, just being able to update the configs without having to compile and flash Marlin. Yeah, that's the biggest advantage I also see for Clipper. So for this good thing, we have like the microfit connector here. So this being the toolhead board we want to use, which is a EBB 36. And so we need then a microfit connector on one side. Oh! Look what the nice folks of Big Tree Tech gave us. That's the better version of the crappy plastic part we made. I didn't see that they were in there. Very nice. So basically this is the microfit connector. So we need to make one of these with 4 cables. I'm not quite sure yet what kind of cable I'm going to use here. Because there's like a little bit of power going over that, right? What do we have here? I have 24 gauge silicone cable, which might be enough actually. I think this one is too thin. This would be very nice if I could use it, but it's not. I think it's too thin for transmitting the power. Let me actually quickly check what this is. 1 second. SKR. Wait. Let me quickly check. What did I buy there? 26. So this is 26 gauge wire. Are your printhead rods solid? Yeah, they're solid. So not all of them. I kind of mix and match. This is a prototype. So yeah. You see the shiny ones here? These are shiny. The shiny ones are solid and they're steel. And these are used basically left, right, like everywhere where like a bushing is running on them, they're like those metal ones. So the metal ones are used here, 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 and there. And then on the verticals, these are also. And then the matte ones here, these are aluminum. These one here, here, like on the side, everywhere, these are all aluminum. And they are partially hollow and partially not. I first went for the hollow ones, and then I started using like, I actually have to. So these are aluminum ones and partially hollow, partially solid. Cat6 cable uses 2 pair twisted together and power 1 pair for data. Yeah, but I only have 4. Like, let me quickly check how much amperage we can carry on 26 gauge. Not just printed ones would say they must be solid. Yeah, they are solid. They are solid and these are solid. Let me quickly see. So if we check for max amp 26, 3.5 is what this random Google result says. Which would give us at 24 volts 84 watts, which is plenty, right? It should be plenty. So if we, I mean, the only thing that draws a lot of current here is the heater, right? Which is 40. Let's say the rest is 10, which is like grossly overestimated. That would be then 50 in total. So 50 by 24 is 2 amperes. So we are like around half the rating. So I'm kind of fine with using that, to be honest. Because this is like a really nice cable for like umbilical. If we combine it with like one string of the same thing we also used for the switch wire, which is like a more solid thing, we can use this as umbilical. So if we just get a healthy length of this. Which is the random length. I think we can quickly make a canvas cable from that. If you have the backlash, if they are hollow, you will never be able to level the bed ever again. Well, I think it will take quite a lot of force to bend them. But yeah, so basically this is a prototype, and I accept that it's not perfect. My goal right now is to finish this printer and make it print. And once I'm confident that like the worst bugs are ironed out, I will go ahead and basically take it apart completely. I will reprint all the parts, and then I will build it again. And for the again, I will use solid core wires for sure. It's just like basically now, yeah, I have them. To be honest, I get them from the hardware store. And the hardware store I can buy them at, the solid ones, is quite far away. So for me it takes like 2 hours back and forth getting them, and I was just not in the mood so far to go there and get more. And that is the primary reason why I didn't swap them out completely. So it's just some laziness. The EBB 36 you got is the one without ADXL. Is it the one without ADXL? Is that where the ADXL is supposed to go? I think it was the one without the temperature sensor thingy. Without ADXL would be not good. Oop, that was the wrong one. But I will confirm what I got in a second. Okay. Let me quickly see which one I ordered. Maybe they cheated me. I got this one. Type 3. And this one is missing, this part here, and I think this is the temperature sensor thingy. Which one is the ADXL? I have no clue. I guess this one? One of these. But I'm pretty sure I have ADXL. That was one of the main reasons why I wanted it. Yes, it has no ADXL? Is this the ADXL? What is type 3? No, I didn't pay attention when I bought that. I mean, right now we don't need it. Where does it say what type 3 is? Oh, so I assume that max 31865 is the ADXL. Oh, by the way, you have a very high resolution picture of my arm. So I should have bought this one and I got this one. Ah, okay. Well, then I get another one. But for now, this is fine. Like, we don't need the ADXL for now. At some point we want to have one, of course, but for now it's fine. Let me quickly see. So there's one cable with a marking, and I want that cable to be ground. So this goes here. So this is why the cable, the EBB was so cheap. Because it was only 15 euros. My understanding was the more expensive version has like a better temperature sensor. Here, that's a neat CAN cable. And then the other side, we need, yeah. But then I would say, like, I prepare this. I will flash this between the streams. And the next time we can build the tool head. Given that the part is here on time, I'm not quite sure if it will make it. Max 31865 is the temperature. Yeah, exactly. That's what I thought as well. And like the highlights in the picture, here they say like with max 31865, and they highlight this spot here, which is the empty one. Well, to be honest, we will find out when we connect it. This is what I would say. But to be honest, I'm not quite sure which one. I mean, it could be one of the small chips here. I have no clue. And the description is not very descriptive. No, it's not really descriptive. IDXL. Well, it says it has one on board, and it doesn't specify any tube type. So I think it has one. Ah, here. It looks like this. Three, 4, 5B. Yeah, I have this chip. This is here. Yep. This one. This one has the same label as the one they highlight and say ADXL 345. And it also has 345 on it. It says 345B. Not sure if I can. Oh no, it's upside down. Here, Steve. 345B. So it's this one here. Can you make a list of all the components used in this printer and post it in the description or the comment section? Yes. So basically this is not ready, so I'm not going to publish anything. This is just a random collection of things. I'm not sure this will work. So once everything is ready, I will publish all the parts and everything. But this is not something you should copy. This is not working. Maybe in half a year. But for now, this is not recommended to copy. No worries, Steve. I'm very happy you're sometimes also wrong. Cool. Okay. Yeah. Then I think I would also wrap it up. Dave, I have to go. I subbed so I can keep up with your build. Thank you, Dave. By the way, I'm exactly at 2,500 subscribers. Like now, I think 2,501. 2,502. 2 people subscribed. So I guess it's kind of like a milestone in a certain sense, 2,500. So yay, party. Yeah, no, it's quite cool. It's quite funny. Like if I stop streaming every week, the new subscriber count really goes down. So it's like only like 20 or something. And when I really stream every week, then it picks up over time. And now we're at like 70 subscribers in the last 30 days. So at this pace, maybe we get to 3,000 by the end of year, which would be pretty cool. Cool. Yeah, but then I said now multiple times, but I will flash this with Clipper. So next time we build a tool head, if the part is there, and we build the bed with this mount. So I will not work on the updated mount because I'm a little bit short on time at the moment, which is unfortunate, but we will have to work around that. In case the part is not here next week, we might do an odd switch wire stream in the middle, where we just basically try to fix the switch wire. I might work a bit on switch wire already. I'm just really tempted to work on that because I really want to figure out what is wrong with the printer. I feel like I'm so close on having all the issues fixed. So yeah, cool. Okay, then thank you everyone for tuning in. Quite a lot of people watching today, so really cool. Also here, like the more I stream regularly, the more people show up, so that's quite good motivation. And yeah, I'm really happy with the progress today. No tool head, but we have a moving Z axis, which is really cool. It's moving quite well, so thumbs up. Cool. Okay, then enjoy your weekend and see you next week.